Problem 26 asks us whether a measure of angle 5 equals the measure of angle 6. So let's find these two angles. Angle 5 is here, angle 6 is here. I hope you see that they both share the same transversal K as it cuts across the parallel lines R and S. And they're both in the same position relative to the points. Okay, they're both in the lower right-hand position as this diagram is drawn. So they are corresponding angles. Corresponding angles have equal measure. So this is true because they are corresponding angles. Is angle 10 equal to angle 7? Is the measure of angle 10 equal to the measure of angle 7? Well, angle 10 is over here. I'm just going to draw it in. And angle 7 is over here. Since we don't know if they're equal, I'm going to use slightly different symbols for the two of them. Are they congruent? Well, we certainly haven't learned any theorems about these two, right? Because after all, they don't share a transversal. 10 is created by the intersection of line R and K, and angle 7 is created by the intersections of line G and S. But let's try to use our theorems and a little creativity to see if we can come up with an answer as to whether angle 10 equals angle 7. Well, what do we know? We know that angle 10 is equal to angle 2. How do we know that? Well, they share the same transversal R, which cuts across lines H and K, and 10 and 2 are corresponding angles. So we know that angle 10 is congruent to angle 2. Well, for the same reason, angle 2 is congruent to angle 1. They have the same measures as well. Okay, so by transitivity, if 10 equals 2, measure of 10 equals measure of 2, and measure of 2 equals measure of 1, the measure of angle 10 equals the measure of angle 1. We're getting closer and closer to 7, aren't we? We're kind of inching our way upwards. But how are we going to get from an angle over here to an angle over here? Well, so far we've been using the fact that G, H, and K are parallel, and that R is a common transversal to all these angles 10, 2, and 1. But a little bit of reflection will reveal that lines R and S are also parallel, and that if you look at G as a transversal, it cuts across R and S, and now angle 1 and this other angle over here, which we don't have a name for, I'll call it angle 11, since that comes after angle 10, angle 1 and angle 11 are also congruent because of corresponding angles as well. Okay, think about it. They're both cut by the same transversal G. There's parallel lines R and S, and they're both, with respect to their corresponding points, on the upper right-hand side. So now we've got angle 1 congruent to 11, which makes 10 congruent to 11. So the question is 11 congruent to 7? Well, I think you can see here 11 and 7, that's a lucky pair, isn't it? 11 and 7 makes up a linear pair. Well, are linear pairs congruent? Not usually, right? So we cannot conclude any way we do it that measure of angle 10 equals the measure of angle 7. It's just false. There isn't a justification for it. But there is one situation where it might turn out that angle 11 and 7 are congruent, which would make 10 and 7 congruent. Can you see what that situation might be? When are linear pairs congruent? If they're each equal to 90 degrees. Okay, so if these lines R and S are perpendicular to G, H, and K, then and only then is angle 10 congruent to angle 7. But since that's not usually the case, we cannot conclude that that's true here. We're not given anything about perpendicularity, so we have to say that this is false. Let's move on to the next one. The measure of angle 9 equals the measure of angle 10. Let me use a different color here. So let's now overwrite 10 with the pink and overwrite 9 with the pink. So the question is 10 equal to 9? Do they share a common transversal? Yes, they do. They share R, right? And when R cuts H and K, creates angles 9 and 10. So 9 and 10 are interior angles. They're between the parallel lines, and they're on alternate sides, opposite sides of the transversal R. So they are congruent. The answer is true. And that's because they are alternate interior angles. And finally, the measure of angle 3, is that equal to the measure of angle 4? Take a look at these two angles. I hope you notice that they are on the same side of their common transversal S. They're on the same side of S. And as S crosses H and K, that's where it makes angles 3 and 4. So 3 and 4 are interior. They're same side interior angles. Are same side interior angles congruent? No, they are supplementary. We just learned that. So therefore, in general, this is false, except again, where both of these are right angles. So where both of these are right angles, it will be true, but that's not usually the case. So it's false because these are same side interior angles.